Hello, good morning. Let's start the class. Well, we'll continue study some problems in number theory. Okay, this is a problem I want to begin with. I think this is one of the homework problems. So here's the question: how many ordered quadruplet A, B, C, D, E have coordinates of values -1, 0, or 1, and satisfies this equations? So how to begin with, right? This problem. Okay, first of all, you make some observations, Okay, you shouldn't know that 0, to any power is 0, right? That's simple observation. Okay, please mute here. Okay, 0 to any power, right? Is 0. But plus minus -1 square is going to be plus minus 1 and to the fourth power equals 1. Then but plus minus 1 to the q and plus minus 1 to the fifth is going to be plus minus 1. Okay, it depends on sign. Yeah, Jen, and mute you. Okay. So the value for each a, b square, c, q is d to the fourth power and e to the fifth is one of the values. Okay, because we know that that they're a, b, c, d, e, right, and have coordinates of values of plus minus 1 and 0. Okay, so when you even put square there, cube it, and they're still the only place is b square and d to the fourth power. It's always come out either 0 and the positive 1. Okay, so there are only two positive patterns. Okay, so in order to get a 2, right? How to get a 2? Okay, let's find numbers. Okay, let's forget those cubes. Okay, so how to get 2, right? And you have the 1. That is we don't consider order right now. 1 plus 1 plus 1 plus -1, then plus 0 equals 2, right? That's one possible pattern. Okay, using the values either +1 or -1 or 0. Okay, another possible pattern is you don't have a -1 there. Okay, and then if you don't have a -1 there, then the only possible pattern is going to be 1 plus 2 1s there and 3 zeros there, right? Okay, if there's one -1, then you have to have a 3 1s there, minus plus -1 plus 0. Now, how about can I have 2 -1s? If you have 2 -1s, okay, then you must have 4 positive ones, but then you have more than 5 numbers here. Okay, so we divide the terms in the equation in 2 groups. Okay. In 2 groups. Okay, the first group is A, EQ, CQ, e to the fifth. Another group always give you positive or 0 now. Okay, so then you study each case. Okay, so let's look at the easy case one. The first case is 1 plus 1 plus 0 plus 0 plus 0 equals 2. So look at this case. How do we, yeah, what kind of, yeah, there are several possibilities, okay? Now let's take a look at b squared b to the fourth power, right? This one we say, we know that's never be negative, right? It's either 0 or both are 0, right? If both are 0, okay, then you can have other group, right? And here b squared b to the fourth, and the 1 is 0, other one is 1. Then the third case is both are equal to 1. Okay, so let's take a look at in this case, in this case, a, yeah, that's a CQ e to the fifth is going to be 1, 1, 0, right? Because you only have 1, 1, 0, 0, 0. And in this case, a EQ and CQ e to the fifth is going to be, you only have 1 ones and 2 zeros. And the last one, a EQ CQ e to the fifth is going to be 0, 0, 0. Okay, now you can find out how many possible ways to write. Well, the first one, okay, B must sorry, B no, what did I say? B D. This is always D. Yeah. Okay. The first one is B and D have a unique solution because B must be 0, D must be 0. But ACE, okay, ACE, okay, how many solutions you're going to have here? Well, if A equals 1, C cube equals 1, and the E equals 0, then E to the fifth equals 0, then you get a one solution, right? ACE, right? Because those are the, integers. But if you permutate, yeah, those ones, right? Regroup them. Then you get another set of solutions. So there'll be 3 solutions. There's a number of solutions. Okay. So number of solutions, you have 3. You record it. Okay. And when d squared, b squared d to the fourth power equals 1, 0, then you have 2 sets of solution here. Okay. Then you have 2 sets of solution here. Then how about a, C, Q, E to the fifth? Okay. Then you have 1, 0, 0. It can have a 0, 1, 1, 0, right? You have 0, 0, 1. So the question is how many of them? Okay. So the first one, okay, how many solutions are you going to get? Well, if b squared equals 1, then b could be plus minus 1, right? And if d to the fourth power equals 1, then d is going to be plus minus 1. So you have a four sets of solution here, and 3 sets of solution here. Okay. So that's why total combination is 12, because 3 times 4 equals 12. Then you look at this one. B squared equals 1, d to the fourth power equals 1. So b is plus minus 1, right? And d is plus minus 1. Okay. Total, you have 2 times 2, which is 4. And this one has just only one solution. Okay. The combination is going to be just 4. Okay. So you have 4, so you get all the possible solutions from here. Okay. Now the second case is 1 plus 1. There's negative 1 there, right? Plus 0 equals 2. Okay. So first of all, let's see. B squared d to the fourth power, both are 1 and 1. Okay. In that case, A, c cubed d to the fifth must be 1, -1, 0. Okay, and that's the easy case. So how many solutions you're going to get here? 4. Why is it 4? B equals plus minus 1, D equals plus minus 1, right? And how many solutions you're going to have? Well, you just permutate those three numbers. Okay, so total will be 6. Okay, 6 solutions. Then 4 times 6, you're going to get 24. Okay, total. Okay, then you know, it cannot be, -1 cannot be here. So another one is you have a one, only one there, and then another one must be 0. In this case, you got here's a 1, 1, -1. So similarly, well, how many solutions are you going to get here? I think it's still 4. Okay, so if B equals 1, B squared equals 1, B equals plus minus 1, then D 0, and switch it. So total is 2 plus 2 equals 4. Okay. How about here? This is still similar. You always have a unique solution. If A equals 1, C cubed equals 1, D to the fifth equals -1, then A equals 1, C equals 1, D equals -1. So then you permutate those three numbers, that's 6 choices. No, 6 choices. No, sorry, 3 choices, not 6. You can have a 1, 1, -1. You can have a 1, -1, 1. You can have a -1, 1. So it's 3 only 3. So total 3 times 4 equals 12. And I think that's all. Why? B squared d to the fourth does not contain, this group does not contain -1. Okay. So either you have a 1, 1 or 0, 0, 1, 0. So add all the numbers together from above, total. How many solutions? 2 plus 12 plus 4 plus 24, and the last one is 12. Total is 55. 55 solutions. Yeah, d to the fourth power, yes. Okay, so so to solve this type of problems, the idea is that you have to divide them into several cases, and then trying to solve them in each case. Right, you're trying to solve them in each case. Right, and even, you know, yeah, and let's go over quickly, right? So first of all, you just look at the result, you know, after you plug the values of A, B, C, D, E. Then the possible pattern is 1, 1, 1, -1, 1, 0 equals 2. 1 plus 1 plus 0 plus 0 plus 0 equals 2. Okay. Then this is a key step. You have to reorganize those 5 numbers and in different orders, okay, in different groups. Then you focus on that group first, the second group, okay, and in each case, yeah, then you have 3 possible, 3 possible sets here, okay. Then in each set, you know, you get a solution. You count how many solutions. Okay, that would be yeah. This is yeah. So this is how to do that. Okay. My next problem I want to do is yeah. Let's have a slightly easy one. Okay. The question is, what is the value of 1 plus 4 to the 1/2 plus 6 to the 1/2 squared plus 4 to the 1/2 cube plus 4 to the 1/2 to the 4th power. Okay. So Erika, you want me go over the first problem again? Erika, oh, I just see a message. All right, let's go back, okay? Okay, you were trying to solve this equation, but they already know A, B, C, D, E, they can only take the values -1, 0, +1, okay? So now for the five, so they are, after you plug these values into the equation, each term either 0 or 1 or still -1, right? Right? When you can get a -1? When you plug a -1 into the cube and into the fifth. Okay. Then you look at the possible ways to get 2, right? Right. So you notice that. Then you can have 3 ones, 1 -1, and 0, and you can have 2 ones, 3 zeros. And those are the only 2 possible. But it's not corresponding to the same order like AB squared C cubed, right? So we try to we divide the 3 terms. We divide the 5 terms in the equation into 2 groups. Okay, so in the 2 groups, okay, and there's B squared D to the 4th and A C cubed E, right? So when we add them together, okay, this could be, then this, look at the picture here, and we don't know which 2 terms coming from B squared D to the 4th power, okay? And so there's three possibility, and the B squared D to the 4th power could be both 0. Then this 2 will be, this 3 will be from this group, right? Okay, from this group. Or you have a, B squared D to the 4th power. You can be 1 and 0. I don't know which one is 1, which one is 0. Okay, so that's why we just use this notation means a group. Okay, it's the order doesn't matter. Okay, the third possibility is B squared D to the 4th power. Okay, is a set of 1 and 1. Now, does it contain 2, 1? Yeah, just 0, 0, and all the possibilities are included. Okay, then you can easily determine the group of those 3 numbers, right? So the next step is just to count, okay? How many possible, just like a tree, right? How many solutions from the first group, okay? This solution is just only 1, B is 0 and D is 0. And here, the number of solutions is going to be 3. Why 3 solutions here? Because it could be A equals 1, it could, look at it. A equals 1, C cubed equals 1, E to the 5th equals 0. And you get one's unique solution. Another one, could be A equals 1, C cubed equals 0, and the E to the 5th equals 1. And you also have a solution, right? One solution. Okay, and just so on. Okay, so you get the third one. Yeah, the third one is A equals 0, and C cubed equals 1, E to the 5th equals 1. So that's why you have 3 solutions. And similarly, okay, you do the rest of them. Okay, that's what I'm trying to explain to you. So now you have this is a number solution I recorded at the end. Okay, and here you have 4 solutions, 3 solutions, 4 solutions, 1 solution. The why you use a product because one side, you divide them into 2 groups. So one side, this 2 independent groups, the one side you change a little bit, and the other side, if you even don't change, you still get a new sets of solution. So that's why, if you write 4 first, then 4 times 3, it doesn't matter, the order. Okay, that's still 12. Okay, And similarly, you can find all the solution in second case. Okay. All right. So this problem, yeah, think about this problem. What is a quick way to solve it? Right? You cannot do one by one. That takes much more time. Of course, you still can do it, but it really takes a much longer time. You should be familiar with the following formula. Okay, you should be familiar with the following formula. So here's a general formula. Okay, x plus y squared is going to be x squared plus 2xy plus y squared, and x plus y cubed is going to be x cubed plus 3x squared y plus 3xy squared and the y cubed. Okay. Then you also will see so there is a way to determine the coefficient. The coefficients like that. This 1, 2, 1. Then this one, add them together with 3 and 1. Then you have 1, and those two will be 4, and that's a 6, and that will be 1 to the 4, and this is a 1. Okay, so this will be x to the 4th plus 4x cubed y and plus 6 x squared y squared plus 4xy cubed plus y to the 4th power. Now that's enough, okay? So compare with above the expression, right? You will see that it's going to be, I think it's going to be 1, x equals 1, y should be equal to 1/2 to the 4th power. That would be 1, 4, 1/2, right? Yeah, 4 times 1 times 1/2, and 6, 1/2 squared, and then here 4, 1/2 cubed, then 1/2 to the 4th power. Okay, then that is going to be, add them together, right? That's going to be 3/2 to the 4th power. So denominator is going to be 16. The numerator will be 81. Right. So this problem just tests you how to expand x plus 1 to the nth power. Now, in general, okay, x plus 1 to the nth power. And how do you get the formula, right? So we do have the formula here, x to the n1, and this is the n1, x to the n minus y. This is the n2, x n minus 2y squared, and keep it going. And in general, it's x nk, x to the n minus k, y to the k's power. Okay, the last one is n minus 1, x, y to the n minus 1, and the y to the n. Okay, so you can derive the formula by yourself if you're assuming this is in that form, and it actually turns out to be, this will be it's given by this number. Okay, so yeah, this is a formula in general, and I think it's a useful. This is a useful formula. Okay, and now if you may try to prove this formula. How do you prove that? It's called the induction method in mathematics. You prove this formula is true in the case when the power is n, then you use that to prove the formula is also true when n plus 1. Okay, and in the public school here, there are very few, teachers probably don't just teach proofs in the classroom. That's why it's not a, yeah, I'm not going to spend time to teach you how to prove some inequality like that. Okay, first of all, you by conjecture, by looking at the examples, you find out x plus y to the nth power must be in this form, right? But you don't know when n is larger, you don't know the coefficients, right? So you find the relation between the coefficients, and finally you get a formula like this. But okay, our next problem is, okay, when 8 to the power 10 times 5 to the 22 is multiplied out, right? How many digits does the number have? Right. Yeah. So we want to know how many digits does the number have. You try this, okay? That's not that is not a very difficult problem. But you have to find a way to estimate the number of the digits to calculate. Yeah. Right. Heather has an answer. How about as a student? Right. So first of all, you notice that 2 times 5 is going to be 10. It's easy to handle 10, right? Okay, so 8 to the power 10 is 8 is 2 cubed. Okay, so you will get 2. You will get 2 to 30 times 5 to the 22. So let's try to find the 10 first, right? So be 2 eighth power and 222 times 5 to the 22. Okay, so you combine them and you will get, combine them, you get 10 to the 22. Okay. So 2 to the s power, it can easily compute it, okay, which is going to be 256. Now you can tell how many digits. So as a number of digits is going to be, first of all, you get 3, then you add the 22 zeros, so total is 25. Our next problem is how many positive 2-digit integers are increased by exactly 9 when the digits are reversed. Let me show you example first. Suppose you have suppose you have a 98, okay? then you reverse it and you take the difference. You find out it's 9. Okay, this is one example. 98 is such a positive 2-digit integer. Okay. Maybe there are more than, right? Okay, so you probably find out, okay, how about 80, 87? That's also 78, that's also 9. But the question is, are there the only those, you can reduce, 21 minus 12 is going to be 9, then that's it, right? Total, you're going to get an 8 here, no problem. But is there any other possible solutions? Okay, in order to solve this problem completely, you have to look at the general case, AB, okay, that's 2 digits minus BA, right? That should be equal to 9. But AB is going to be 10A plus B. And here's 10B plus A, okay? So after simplifying, 10A minus A is 9A, B minus 10B is 9 minus 9B. So it's 9A minus B, okay? And this one to be 9, so A minus B must be equal to 1. You just need to find how many solutions there, right? So then it's easy to count, right? Because once A is determined, B must be determined, right? A equals 1 plus B. So B could be, right, positive digits. So B cannot be 0, right? It can be B0 or not, right? If B0, A is 1, right? Okay, B0, right? In case, let's see, how many positive digits, right? If B0, right, then A equals 1, right? And the B equals 1, A equals 2, B equals 9, right? B cannot be 9, right? B equals 9, then A equals 10, so B equals 8. Okay, so the question is, look at the first case, when A equals 1, 0. Okay, this doesn't make sense because this is impossible. This should be excluded. Okay, that's why you only have 8 solutions. There's no other solutions. There are only 8 solutions. Right. Our next problem, it is also, well, I don't want to give you a very complicated problem right now, but we are going to discuss a bit more complicated problems later. Okay. So we know that the sum of 2 numbers is 15, and their product is 16. What is the sum of their reciprocals? All right. Yeah, please try this, Yeah. All right. So just two numbers, right? The sum is going to be 15. The product is going to be 16. How to find just write down this, right? How to find the sum of the reciprocals? Well, you have to modify this expression, right, in order to find the sum. Right? Can you do that? Right, so it's going to be just, yeah, n times n. Then you see that, oh, that's easy, right? It's a 16 over, and over 15 over 16. Now, another question is, are there solutions? If this is a problem, okay, this is in spring round, then there's a possibility the answer will be no such numbers there. So the answer could be no solutions. Okay. So if you have extra time, you should check, we assume, right? But then this assumption is wrong, the sum of the two numbers is 15 and their product is 16. So are there solutions? Well, if you look at the number carefully, it does not say this number must be integer, okay? So if this number is not necessary to be integer, then such numbers exist, okay? But let's try to find these numbers, and look at this. How do you find the equation? Right? How to find the n, right? So you buy, n equals 15 minus m. So you put there, right? So 15 minus m equals 16. We don't know yet. Possibly there's no solution, okay? Use a quadratic formula. If you get, okay, if you're able to factor this, then you get a solution immediately, okay? And if you cannot factor this, I think you can factor this, right? So it's going to be 1 and negative 1 and 15, right? And minus, no, I don't think so. Let's just use a quadratic formula, okay? So if you use a quadratic formula, you get two solutions. I want to make sure you get real solution, real numbers. Otherwise, no, right? It's 2, 15 plus minus negative 15 squared minus 4 times 16, okay? And so you will get, yeah, inside, yeah, okay, it's going to be 4 times 16. It's 161. It's a positive number. So you do have two solutions, okay? So if m is going to be 15 plus square root of 16 when divided by 2, then n is going to be 15 minus, okay? So either way, they're in the same order. So you, okay, yeah. So you cannot factor it, right? Yeah. This is what I got, yeah. Right. So those are the irrational numbers. Then such a number exists. But if you use this solution to find the answer, that's very complicated. You have to do it directly. That's a simple way to do it. Okay. Yes. Okay. Our next problem is for particular list of 4-digit integers. Okay, we have four distinct integers. Okay, not 4 digits. Distinct means they're all different. Okay, it cannot be same. 4 distinct integers. Okay, so the mean equals the median. equals the range. Okay, so they have the yeah, the mean, median, and range have the same value. Okay. Okay, we also know that the least integer in the list is 10. What is the greatest value for the integer in the list? Right. So you have 10 numbers, right? Now you have 4 digits. Let me begin with them. You try to think about. So you can list them in the order, right? Because they are different, distinct. So you can arrange them in this order. Okay, 4 distinct digits, integers, and the list of integers is 10. So you only have 3 variables here. So what's the definition of the mean? Okay, so definition of the mean is going to be 10 plus A plus B plus C, right? Divided by 4. The median is going to be the middle one, middle 2, divided by 2, because this is even numbers, right? So you have 4 numbers. That's why 2 middle one, the average value. The range is just the difference of the largest number and the smallest number, so 3 minus 10. So those are the formulas, right? Now I wanted to try to find C if possible, right? What is the greatest possible value for C? Right? C is already denotes the greatest value of the integer in the list. Yeah, with the last couple of problems are more complicated. All right, Richard got an answer. Anybody else? Erica also has an answer, but Grant's answer is different from the rest of them. So you can double check the answers, maybe not 20. Maybe 30 is correct, right? 2 of you got 30. Right. So Erica got 20. Okay, let's try and see how do we solve this problem. Right. So we by assumption they're all equal, right? By assumption all are equal. Okay. So 10 plus A plus B plus C equals 4, right? And that's equals A plus B equals 2. That's C equals minus 10. So you can always replace A plus B by this, right? Okay, right from here, by here. Then you put it into this equation, okay? So you will get 10 plus 2C minus 10 plus minus C divided by 4. Okay, this is equal to C minus 10. Okay, then you solve it. Okay, solve this equation. Yeah, solve this equation. Yeah, right? Then you get, you have a 3 equation. You have how many equations? You have 2 equations, but 3 unknowns. But 3 unknowns, A plus B is one, you can view as one variable. So actually two unknowns in. Yeah, then you have a 10 plus 2C minus 20 plus C equals 4 times is 4C minus 40. Right, so this will be 3C minus 10 equals 4C minus 40. Let's move the, yeah, so C should be equals 30 anyway. So that is that is the answer. Okay. All right, so that is the answer. All right. So our next problem, yeah, I want to take a look at. Let me show you another problem. Yeah, this is a problem not good. I'm going to give you another. Yeah, wait this. Okay, okay. Our next problem is, what is greatest 5-digit parent German n such that 7n is a 6-digit number. Not only 6-digit. Okay, this is a 6-digit similar number. All right, so this is this it, palindromy number is going to be like that 121 something. It's a 3-digit, right? 5-digit, 4-digit is like 1221, you know, and 5-digit will be 12321. So this is a 5-digit. It must be in this form. And it must be in this form. So we are going to find a 5-digit number such that 7 times that number is also going to be 6-digit palindrome. Okay, so 5-digit number must be in the form A, B, C, D, A. Okay, so when you write a number in that form, you can decompose it. Yeah, this is a B and 100C and then 10B plus A. Right? So you can add them together. Now, when you multiply 7, what do you get? You get 70007A, 7070B, and 700C. So this should be also should be a 6-digit number, first of all. Okay, 6-digit number. This is a 6-digit, right? 6-digit. So when it's not going to be 6-digit, I think this make a bigger contribution here. Okay, so if you choose, yeah, you will see that. Okay, and you find out no matter which number you choose. Let's see, how do you get a 6-digit number, right? It cannot be too small. Okay, otherwise, yeah, how many zeros in the middle? Yeah, right. It's a 5-digit. You want to get 6-digit, right? If this number is too small, you're not going to get 6-digit, only 5-digit. Okay, so you have to try 9, 630063. You can, yeah, you get a 9-digit, 6-digit, right? And plus 8 and the 560056. Now that's the way how to do it, right? So it's easy to compute, but now you also have to look at. Be careful, because if this number is too small, you are not able to. Yeah, let's look at the second part, right? Second part, 6, right? And 770 times 8. It's a 56560. Okay, so you can yeah, just take a look at this 2 first, right? And add them together. Okay. We also want to get palindromy number. That's the problem. Okay, that is the problem. So let's look at a few examples first. Okay. So you will get 6939693, and this is clearly not a palindromy number, right? But we only look at this 2 here now. We haven't checked the last one. Now those are three numbers here, right? A, B, C. You have to determine 3 digits. And let's try another combination. Now, why we have to do that? Okay, we try to at least find the one, and you cannot try all of them, right? So there are, you see, A, B, C. There's those digits. They can change, right? How many of them there, right? For A, you have 9 choices from 1 to 9. B, you have 10 choices. C, you have 10 choices. Total is 9 times 10 times 10. That's wow, 900, right? But you are looking for the greatest one. So if you want to looking for the greatest one, you have to use larger greatest integers as possible. Try those, right? Try B and C. That's the reason I only consider A equals 9, B or 8, and B equals 9 or 8. That's the motivation. Otherwise, to say, well, why not to consider others, right? We try to, then you have 4 choices probably, right? 9, 9, you know, at least you have 2 choices for A instead of 10, right? 2 choices for B. Among those possible values, so we're trying to find a way, okay? So that's the motivation, okay? Then you have, 5, 6, 0, 0, 6, 5. Then 6, 3, 6, 3. Let's consider the sum of those first 2 numbers first. Okay, you will get 6, 2, 3, 6, 8, 6. And another one, 6, 1, 6, 6, 1, 6. Okay, now you have to modify. You see, you will add the 700C. You have to add the 700C. Okay, 700C. Which one gives you? Which one gives you the paradigm number? Okay, you have to add the 700C, 700C, 700C. Okay, I think. Yeah, I think this is impossible, almost. Yeah, let's explain to you, but later. Okay, this also will be impossible. And this is impossible. Only the last one is more likely you're going to get. More likely, like the last one is already here. It's a 6-digit, right? 6-digit paradigm. This is already a 6-digit paradigm. Okay. Now you want to find the greatest one. Now this is already a paradigm. Okay. And then you have a couple choices for C. C could be 0, 1, 2, 3. But every time you choose a different digit, you destroy this pattern. Okay. So only possible solution make sure you just get a paradigm is C must be equal to 0. Okay. So C must be equal to 0. Okay. So that implies, you can see that C must be 0 in order to keep the same pattern. Okay. Okay. So the answer is the number is going to be the number n is going to be 88088. Okay. And then 7n, you will see that is going to be 616. 616. Yeah, that's a surprise. Yeah. So the idea is that when you do this type of problem, first of all, you express it in the form like that. So basically, you only have three unknowns. Okay. Then you multiply n 7, then you get the expression like that. Okay, you guys. And in order to find first you're trying to find the right. You're looking for the greatest 6-digit paradigm. So there are so many choices right now, okay? Because A could be from 1 to 9, so it's 9 choices. B can be from 0 to 9, 10. C is coming from 0 to 9, 10. So you have a total 900 choices. So that's too many. But anyway, you're looking for the greatest one. So you begin with, yeah, you can try A equals 9, 8. Then B equals 9 and 8. So at least then you determine the C. Maybe among this group, right, those choices you already get the paradigm, so you're lucky. Yeah. Well, if you still couldn't find one, then you try A equals 7. Okay. And likely that will be happen because this is a problem on the test. So I don't think they're going to let you to try so many times. So that's it. So this, we're not going to try to solve the problem. They're trying to find the logic. What is a shortcut to find such solutions? Okay. But yeah, let's stop here and yeah, have a good weekend.